Welcome to Mrs. Lee's Chemistry Academy. With no students are left behind, today we're going to continue with the Oxidation-Reduction Reaction. Tying to the learning objectives from College Board, basically we would like to learn what is Oxidation-Reduction Reaction, learn how to balance it using two methods, and that when we observe a chemical change that we can relate it to the reaction itself, or we can relate it to the particulate drawings. And also to design an experiment involving a redox titration. So a recap of redox reaction, it involves transfer of electrons from species oxidized to species reduced, and we use the acronym LEOGR, and oil-rich, meaning losing electrons oxidation, gaining electron is reduction. And be sure that number of electrons gained and lost are equal. Now let's first review what are oxidation states or oxidation numbers. These are numbers arbitrarily assigned to an element in a chemical formula, and we use it to track the movement of electrons. The rules are any element that's neutral oxidation number is 0. If they are metals, Group 1 has a charge of +1, Group 2 has a charge of +2, and the Group 3 involving aluminum has a charge of +3. Oxygen usually has a -2 oxidation number, other than in hydrogen peroxide, where it is regarded as -1. Fluorine is -1. Hydrogen is usually +1, except in metal hydrides, such as calcium hydride, where hydrogen now has an oxidation number of -1. And if it is a neutral molecule, the sum of oxidation numbers must be equal to 0. And if it is an ion, the sum must be equal to the charge of the ion. And it does not have to be whole numbers. So let's practice with nitric acid, HNO3, H is +1, O is -2. Therefore, N has an oxidation number of +5. I hope that you can also figure it out. Potassium permanganate, potassium +1, oxygen -2, and there are 4 of them. Therefore, for manganese, the oxidation number is +7. In the dichromate, the orange solid or the orange ion in solution, chromium is +6 and oxygen is -2. Therefore, the sum will be equal to -2, the charge of the ion. For propane, C3H8, because hydrogen has a +1 oxidation number and there are 8 of them, so each carbon has a -8/3 oxidation number. Remember I said it's not going to be an integer all the time, so the sum of that molecule for oxidation number is 0. Now, there are a number of species that are usually involved in oxidation reduction. One is permanganate ion, second is the dichromate ion, and third would be the hydrogen peroxide, the one that you can buy from your drugstore. Now, they are involved in redox reaction that permanganate ion is reduced to Mn2+, dichromate ion is reduced to Cr3+, and the O in hydrogen peroxide is oxidized to oxygen and also reduced to water. And you don't really need to remember the products because usually they are given in an equation. The hints will be given, but you need to know how to balance it. Balancing redox reaction, we have 2 methods. One we call the electron transfer method, or we also call that the oxidation number method. First of all, we predict the products. If one is oxidized, the other one will have to be reduced. And now we balance the atoms on both sides without the H and O. Leave that till the very last minute. Now you determine the total oxidation number of the elements oxidized and reduced. Then you indicate the number of electrons gained or lost. And then you make sure you multiply that by an integer to make the electrons equal. And now you balance your oxygen atom using water to balance it, and then you balance your H atom using hydrogen ion. And at the very end, you check that the atoms are conserved and the charges are conserved. So here is a problem for our practice. A solution of iron 2 ion added to acidified solution of potassium permanganate. So we have iron 2 plus ion, and I don't bother to write an aqueous, but being a charged ion, it is an aqueous solution, and permanganate solution. Now I wouldn't bother to write the H plus yet. I wait till the very end to do it, knowing that it's happening in acidic solution. This iron 2 plus will be oxidized into iron 3 plus ion, and the permanganate ion will be reduced into Mn2 plus ion. So if you look at the oxidation number change, now we look at total oxidation number change. For iron, it has gone from +2 to +3. That means it has lost 1 more electron. Losing electron is oxidation, so we put OX over here. Now the other species of interest would be the permanganate ion. So the oxidation number here is +7, here is +2. That means it gained 5 moles of electron. We call that reduction. Now, knowing that electrons have to be equal, so we decide to multiply this one by 5 to make the electrons equal, and then put in a 5 as a coefficient for the iron 2 plus and iron 3 plus ion. Now, we are ready to balance the oxygen atom. We have 4 oxygen atoms on the left, so we add 4 moles of water to the right, and that creates 8 hydrogen atoms. So we put it on the left as 8H plus ion, happening in acidic solution. Now I check my atom. They seem to be conserved, equal on both sides of the arrow. Now I check my charges. On the left, I have +8 and +10 from the 5 times the +2 and -1. So the net charge is +17. Now on the right, I have 5 times 3 plus +15, and 2 from the manganese ion, and that's also equal to +17. So I know it is a check, and the equation is properly balanced. So here is a recap of my previous work. I put the oxidation numbers in red, and that's total oxidation number. And so once I check the change in oxidation number, I balance the electron, multiply the iron by 5. And then I balance it with the oxygen in terms of water and add H plus to balance the H atoms. And the total charges I checked is fine. Okay? So be sure you check the charges. Sometimes I do make mistakes. When I check my charges, I know that I made a mistake and I go back and correct myself. Okay. The next one. Iron 2 ion added to acidified solution potassium permanganate. This time we're going to do it by half reaction method, the second method. So how do you do it? First, you put your Fe2 plus to become Fe3 plus, oxidized. Now, because the charges have to be equal, I have to do it again. I add an electron to here so that the charges are the same on both sides of the arrow. So this is called losing electron is an oxidation. Now then I write the permanganate ion to become Mn2 plus ion, and adding 4 moles of water to balance the O, and adding 8H plus to balance the H. Now on the left hand side I have +7 charge, on the right hand side I have +2, so I must add 5 negative electrons to balance the charges. Gaining electron is reduction. Now, because I want my electrons to be the same, so I multiply the first equation by 5. And when I do that, I actually cancel out my electrons. So now I can write the overall reaction 5 Fe2 plus and 8H plus and MnO4 minus to give 5 Fe3 plus and Mn2 plus and 4 water. Let me see, 8 and 10. Yes, this is fine. The charges are balanced. So this is properly balanced by the half reaction method. You can choose either one. Some people like half reaction, some people like to do it by oxidation numbers. Okay, here's a recap. Unfortunately, the recap is over my writing, but I hope that you can see it well. Okay. The next question. Permanganate solution mixed with oxalate ion in acidic medium. So we have permanganate solution mixed with oxalate ion, C2O4 2 minus, to become Mn2 plus and CO2 gas. Okay, so first of all, I balance my carbon and oxygen times this by 2 to balance the atoms. Now I look at changes in oxidation number. Manganese has gone from +7 to +2 by gaining 5 moles of electron, and this is called reduction. Now then I look at my carbon to my carbon. This is overall +6, and this is overall +8 because each carbon has a +4 oxidation number times 2, which is +8. Now it has lost 2 moles of electron. I call that oxidation. But then I need to multiply this one by 2. So I put 2 in front of the permanganate, 2 in front of the manganese, and this one by 5. So that I have 10 moles of electron transfer. So I put 5 in here, and I put 10 over here. Now I count my oxygen. I have 28 oxygen on the left, but I have 20 oxygen on the right. So I add 8 moles of water to the right to balance the oxygen. And in that sense, I created 16 hydrogen atoms. So I put 16 H plus in an acidic media. To the left, now I count my charges. To the left, I have +16, -2, -10. So that's a net charge of +4. And on the right, I also have +4. So everything is balanced. I know that I have done my job properly. So here's a recap of my earlier work. You may want to pause your screen so that you can follow my work carefully and practice doing it yourself. Okay, then how do we do it? By the half reaction method. We take the permanganate solution, turning it into Mn2 plus, adding 4 moles of water to balance the O, adding 8 moles of hydrogen ion to the left to balance the H. Now because I have +7 on the left, +2 on the right, so I add 5 negative electrons to the left to balance the charges. The next one will be the oxalate ion, C2O4 2 minus to become 2CO2. And because it's -2, I add 2 moles of electron to the right to balance the charge. Then I multiply this by 5 and the previous equation by 2. And overall, I would have 16 hydrogen ion, 2 permanganate, the purple ion, and 5 moles of oxalate ion to yield 2 moles of Mn2 plus and 8 moles of water and 10 moles of CO2, just like what I had before. So here's a recap of my earlier work to help you to be able to think about what you just learned from my previous slide. So here is the lesson summary, summarizing what we have learned today. We learned how to assign oxidation numbers to species, and we learned how to balance redox reaction by electron transfer method and by half reaction method. I hope that you have found the above lesson useful to you. Feel free to let us know your comments, and I hope to see you again next time.